Okay, I'm going to make what probably qualifies as a not very satisfying uh, video about writing a conclusion for our bowling ball lab. There are example conclusions available to you in Canvas. Look for a page and toward the top of the modules it says example conclusions. You'll find three. I have left some blanks in the paragraphs there. You need to find the words to fill in those blanks. But I'm going to talk generically about what goes into one of these paragraphs. So the first thing we probably want to start with is what did we do? And as you know, we're doing a lot of watching videos. I don't want you to describe watching a video. I want you to describe kind of the act of what we're doing. So in this case, what we did was we rolled a bowling ball down a track and we took some time and distance measurements from it. So that would be a fine, thing to state in your first sentence of this conclusion paragraph. Next thing we want to do is make a claim about the relationship between the dependent and the independent variables. So here, our independent variable, you may recall, was time. It was the amount of time that the ball was rolling down the track. And the dependent variable was the distance the ball rolled down the track. So you should be able to look at your graph and look at your data and say, well, that data is in a nice straight diagonal line. We need a little better word for that relationship than straight diagonal line. So I'm going to propose that a good name for that might be proportional. Some people have been using the term linear. We're going to distinguish between proportional and linear down the road, but right now I'm satisfied with proportional and or linear. So we might say something along the lines of, I found there to be a proportional relationship between the time a ball rolls down the track and the distance it travels in that time. Next, we need to sort of reinforce our claim with evidence. Why do we make this claim? So we want to refer to our data, perhaps. So you might want to look at your graph or an example graph for this. You can see that your data points kind of go up in a nice diagonal line. So you would say something along the lines of, when I collected the data, as the distance increased, or as the time increased, excuse me, as the time increased, the distance increased in proportion to that, or proportionally with the time. The distance and time increase together at the same rate. That's the nature of that straight line relationship. So that just generically refers to our, observations here. And then we need to sort of reinforce it with some reasoning about this, kind of connect to our claim. So the reasoning is usually actually in the form of a mathematical formula, what we've been calling a line of best fit or a mathematical model. So you might find that mathematical model and you might be saying something along the lines of, the model which best fit my equation was y equals 82.2x, or the distance is 82.2 times the time. And if you use y equals 82.2x, you might want to say, well, in this context, y is the distance the ball traveled, and x is the time it took to travel that distance. And 82.2 that's the ratio between the two. But what that really is 82.2 centimeters per second. So remember, this is the slope of our line, 82.2. And slope is rise over run. And rise over run, our rise here, you look at your y label, it's the distance. And our run label, it's the time. So rise over run is really distance over time. And distance over time is really speed, miles per hour, miles over hours. centimeters per second, centimeters over seconds. So that's going to be our last statement. Is making sense of that equation, especially what you know, that 82.2 or whatever number you found. I don't know what number you found. That's just an example number that I pulled out of my butt. That would be the way you're going to connect your evidence to your reasoning, you know. So the evidence is the data, but the data by itself is not good enough. We need an equation. We should find an equation. That equation then connects as a proportional relationship. When you graph a proportion, you're going to get a straight line. So hopefully this gives us a little clarity on what it looks like to write a conclusion, and you should be able to, between this and the example conclusion paragraphs I've shared, you should be able to figure out how to put it all together. So hope this helps.